We want to use centered rectangles of width 0.5 to estimate the integral from 0 to 3 of x plus sine x dx and the integral of 0 to 3 of x dx plus the integral from 0 to 3 of sine x. So what we're actually looking at here is what we've said in the notes, is that the integral from a to b of f of x plus g of x is equal to the integral from a to b of f of x plus the integral from a to b of g of x. And that's what we're investigating here. So we're trying to show that a and b are the same. So I've already got the right values here, which I had from last example. And so in this one, we're going to do equals. You need to make sure your calculator is in radian mode before you deal with the trigonometric, but I've already done that. So equals that one, which is the x part of this, plus sine of that one. And then we'll fill that one down. So edit, fill the range, and that's going to be B1 to B6. Okay, so may as well go ahead and complete this one. And so what we want to do is multiply that by the widths. So that one's going to be equals that multiplied by 0.5, all the widths are 0.5, and we'll fill that one. So we'll fill the range. That needs to go down to C6. Okay, and let's add those ones up. So equals SUM, and that's going to be C1 to C6. And what does that give us? 6.51087. Now to do the function separately, well, column A contains all the x values. So here we could just do equals those ones, and we'll just multiply those by 0.5, which is the width. And then we'll fill that one down. So edit and fill the range, and we're going D1 to D6, and we'd like the sum of those. So equals SUM open bracket, and that's D1 to D6. So D1 to D6, close the bracket. So those come to 4.5. And then we need to look at the sign. So in here we'll have equals, and it will be sine of, and the x values are right over here in A. And then we'll fill those down. So edit, fill range, E1 to E6, and then all we finally need to do is multiply all those heights by the widths of the rectangles, which are 0.5. And so go back here, and we're in column F. So fill range, F1 to f6, and then we want the sum of those. So equals sum, open bracket, we're in column F, so that's going to be f1 to f6, and close the bracket, and that's 2.01087, 2.01087, and if we add those together we do get 6.51087. So exactly what we were trying to show is that the integral of f of x plus g of x is the same as the integral of f of x plus the integral of g of x, provided the limits on the integrals are the same.